Hello and welcome everybody at the third installment of Lunch and Learns. Today we're going to be talking about iterators and generators. I'm going to be your lecturer for today, and my name is Valeria Pervashina. I'm a quantitative researcher at Hudson and Thames, as well as master's in quantitative finance at the University of Warsaw. If you have any questions regarding the topic, or you just want to you're curious about any type of matter concerning the quantitative finance field, please feel free to drop me a message, as my Twitter and Git handle is listed here on this slide, and my LinkedIn and other social media handles will be mentioned at the end of the presentation. So without further ado, let's start. My goal with this presentation is to perhaps show you a new side of generators. And they already are thought about as something that either is talked too much about, or there's nothing else to know about them, or people just don't understand the concept at all and how does it even operate, right? And what I'm going to show it to you is how you either already benefiting from them, even if you're not thinking about it in your day-to-day programming, and other curious and important ways that you can actually benefit from their features more than using them as a fancy iterator in your quantitative finance research. And this is my main goal, to show you the examples of how they can be used and make you change your mind about generators altogether. All right, so without further ado, let's start. You're already benefiting from them. Generators already often are perceived as something mysterious or complicated, or something that is just too bothersome to kind of take a deeper look into. It has this strange yields and strange code. It doesn't return a value, it returns kind of an object, and it's weird and yucky. And a lot of people just don't take their time to actually figure it out. What are those and why do we use them? But nevertheless, most people, most Python programmers, I think even all of them, are using generators in their day-to-day programs. And the best example to show it is our favorite for loops. If you're coming from a different programming language, it's very highly likely that you were surprised by the change in notation from this beloved standard, where we're defining I, the condition while we're continuing to increment our I, well, it's smaller than n, the sign for incrementation. Beautiful, right? Beautiful, standard, classic. And somehow in Python, we could just kind of took it and turned everything on its head by using this weird range function. And it appears to be even faster than using some type of already predefined list of indexes. Why is that? Well, actually, this range function is not is a generator function, is not what it seems. It seems that we're looping through it like we're looping through a list, right? Taking one value after another, but in fact, it doesn't hold any list of values at any space for all these lists of values in memory, and just returns us the current kind of value of our I. But why is that? What actually makes it a generator? And why is it important that in Python we're taking advantage of this functionality in for loops and iterations? So what makes a generator a generator? Generators are a special type of functions that return a lazy iterator using a yield statement. So what we do is basically we're going through our function line by line until we get to a yield statement. And as soon as the execution hits our yield, we are kind of jumping out of the function and yielding this value, right? Yielding this null value. And however, opposite from return, it doesn't kind of exit the function. We're still there. The function is still ongoing. It's still kind of, we can it's suspended. It's not exited from, it's suspended, much like the OS suspends one task or another, jumping while managing multitasking inside the CPU, right? So what we have here is we are suspending our execution during yield. And the next time we're calling to our generator, the execution resumes from this point, not from the very beginning. From this point, it goes through our num, goes back into our while, and yields yet another number. And as you can see in this example, this is exactly what allows us to build something that is actually impossible to do with other types of functionality, like infinite sequences, right? As it doesn't have to use any type of concrete memory allocation except for one element. And despite having the finite computer memory, infinite sequences are not a problem for a generator. And it's a much loved example for many and many textbooks is to show how to make a Fibonacci sequence generator. But in this lecture, this is not what we're doing. We're looking into our practical values and what you can do and how to apply it to your own research, right? So let's go over the points that I mentioned one by one. First, the returned object, the generator, can be looped over just much like a regular list, but without the need to store their contents in memory. So first big benefit, memory, right? Second, after yielding the results, the function is not being exited from, and the current state is memorized, meaning the only one element is saved in memory at a time. Also, another big memory benefit, and with memory benefits come usually speed benefits, as processing big chunks of memory take time, right? And third one is generators allow you to create infinite sequences despite having the finite computer memory. These all three characteristics are main points that most books will teach you about generators, right? And after that, I want to talk about what's in it for quants, what's in this concept of generators that can be utilized by us, quantitative field professionals. So, and it's important to understand why even use them and bother to looking deeper into them, whereas there are seemingly simpler alternatives. So let me present you with 4 core examples of use of the generators, and I have structured them in a way that goes from more obvious ones and easier ones to implement and understand to more kind of complicated and more complicated, and we'll end at one that is a bit more obscure maybe, however opens a door to numerous possibilities. So let's start. First, we have our reading large data sets in Pandas. I'm 100% sure that almost each and every one of you have tried to upload a large file through read CSV function in Pandas and have met a wonderful memory error as the computer failed to kind of process this big chunk of information, big file all at once, and it doesn't have as much immediate memory as we wanted to. So computing larger than memory data sets now is possible by splitting the process into batches and yielding them one at a time. This way, you don't have to hold everything in your memory at the same time. You just can yield one batch and then forget it immediately and yield another, being in line with the constraints of your PC, right? So this is one wonderful way that you can kind of read your data sets in Pandas, doing it chunk by chunk, batch by batch, and yielding the result. But this is one of the most obvious ways, and I think that a number of you who are listening to this lecture have already done it or seen it done in practice. The next 3 are more unusual. So let's start with the market data processing pipeline. Actually, I want you to think of generators not of like the fancy iterators, but rather than your perfect encapsulated functions that are used for processing information. And the benefits of generators are in chaining. By chaining a number of generations, you can create a perfect data pipeline that won't care about the available RAM memory and will allow you to overcome most of your memory constriction working even on the largest files. So for example, if we want to talk about like more development side example, for example, log reading, right? We know that logs are structured in a way to be conveniently read by an eye. It has columns, it has different values, right? You can build a pipeline of iterators chained with each other and process the whole file altogether, as it will apply the operations inside of the generator on the whole data. So let me be more clear. You have a log file, right? First, you will build a generator that will return line by line. Build a generator for line by line separation that will return a line. Let's say it's a generator A. After that, you can take another generator that will take for example, first element in this line A or first n elements for this line A and perform some operation on this. And this can be done more and more times, doing more processing that you would need to. And for example, let me be more specific. For example, fixed messages that Professor DePrada mentions in his approach to data structures. Those fixed messages can be encoded, decoded, and put into very comfortable to use dictionaries using a incredibly fast pipeline of the number of generators stacked one by one, chained one by one, right? And what previously was thought about as very uncomfortable thing that can be decoded only by using like C-oriented language can be actually done in pure Python without even having to install too much of an additional packages, just by building this generator pipeline. Right. The second point is kind of a continuation of what I was already said before about market data processing pipeline. It's live or infinite data parsing, as we don't have to have the whole data to run a generator, as we don't actually exit the function. We're just suspending it once we're coming up to the yield statement, right? We have the ability to process live data fields yielding the outputs as soon as new data is written. So for example, if you're using some type of alternative live data feeds, it's very comfortable for you to have this generator function that will be listening to your data feed, the new file that is, or new log where it's written, and just constantly keeping updating and returning you with new processed values as soon as they were written in the live source. Right? Pretty cool, if you ask me. I think not a lot of people use generators for this, but they are a very efficient way to do so, and actually are incredibly useful for doing just that, for building blocks for pipelines. Right? And last but not least, however, I think the most mind-blowing thing of all is the coroutines. We usually think of generators as something that returns the information, right? So in terms of our first pipeline that we mentioned, the data is being pulled through the pipeline, right, by some ending function. We have our input file or data feed, we have our output, and we have our function that is pulling everything through our pipeline. So for example, dictionary creation, right? In terms of coroutines, the situation is completely opposite. The yield statement can not only be used as statement, but you can use it as an expression. That's right, an expression. And what do I mean by that is you actually can send data to generator while it's executing, right? So at this yield moment, you can send new data into a generator. And this is what's called the coroutine, a generator that consumes data. And in this way, you can enable the data flow style processing with generator. And I'm going to show you a visualization of this on the next slide. So this is a more unusual way to think about generators. Is something that rather not produces data, not consumes data, but no, right, not produces data, but rather consumes it, right? So it's able to send the information to the generator. So we're able to do completely opposite from what we've been told to do with them. I think it's pretty cool. So let's see a bunch of visualizations of those concepts. I credit these both images to David Beasley and his incredible lectures on coroutines and generators, and I highly recommend you to check them out. They are amazing and mind-blowing at the same time. But I'm going to go through it very briefly, one by one. So the first example is the example of an Apache server log processing pipeline, which has a chain of generators, as I told you previously. But here he proposes to encapsulate those chains into logical subroutines and kind of compile them into Python chunks, into Python subfunctions, right? Chaining a bunch of generators. So for example, if we are given a raw Apache server log, first, we would like to have a short chain of generators to generate lines from a set of files in some directory, right? If we're using multiple files and multiple inputs. And after that, we would like to have a separate chunk that can parse a sequence of lines from Apache server logs into a sequence of dictionaries. This example highlights, I think, one of the best parts of generators. This is Unix type approach to functions and operations. So in fact, the second part and the first part, these two kind of logical chunks, can be reused in different pipelines for different data, and they are separate. They are encapsulated in their own purpose. And this is what's beautiful, as you can order different chunks however you'd like, building different pipelines, building different flows, and you have complete freedom of doing so. So this is a wonderful thing, and I highly encourage you to look deeper into that. And the second example is the example of coroutines that I was talking about. So for example, from source, we through send method can send new values to our coroutine, and it will, after it will operate, it is able to send even more values to more coroutines, and thus performing this, creating this like data flow like structure. I find it pretty useful and pretty interesting, and I once again highly recommend you to check it out. But let's conclude this section with a short, sweet conclusion, is that generators are mostly about biting off more than you can chew, as they allow to solve most of the problems connected with RAM constrictions with the power of lazy evaluation and holding just enough information for you to make your operation possible. I hope I was able to kind of change your perspective on generators, or at least make you look on them in a different way, or in a way that you haven't seen them in before. There are more things that can be done. You can slice a generator. You can do even more operation using libraries like Iterators, but this is a topic for another day. Highly recommend you once again to check the High Performance Python book and the lectures by David Beasley on generator tricks and coroutines. They have been huge inspirations of this lecture, and huge inspirations in terms of programming and evolving yourself as a quant. I thank you for being with me during this lecture. Hopefully you enjoyed it. Hopefully you find something interesting for you or something curious. My name was Valeria Pervushina, and I was delighted to be a speaker today. If you have any questions, please feel free to reach out to me, as all of my social media handles are down below. Please press like, subscribe, and see you in the next one. Bye-bye.